Hey, welcome back to school here. It's nice to be able to teach you again, even though it's a little different now. Hope you had a good Thanksgiving, and just praying that you guys are doing well and your family's doing well with all this crazy stuff going on. All right, so we're going to start a new chapter here, chapter 3, topic 3. Um, Look at page 161. If you don't have your book, go get it. And here we go. Hope you enjoy. So this section is on something called rates and ratios. So first, here's some terminology that you might need to know about. Rates and ratios are very important because you guys can use them in pretty much everyday life. So very critical that you guys understand this chapter here. But the quantities x and y and the ratio x over y. Now a ratio is just really a fraction or a comparison between two things. The quantities x and y are simply called terms. It's kind of a vague definition. You'll see terms used a lot of different ways in math here. Um, Now, if you look at these two ratios here, 2 dogs to 3 cats and 10 dogs to 15 cats, guess what? They're the same ratio. Okay, if you reduce 10 over 15, you'll get 2 over 3. If you take 2 and you times it by 5, you'll get 10, and 3 and times it by 5, you'll get 15. So anytime you can, make two fractions the same, those are what we call equivalent ratios. You see? Multiply the top by 5, you get 10. Multiply the bottom by 5, you get 15. You have to multiply the top and bottom by the same number. And if the same number works to give you the other fraction, it's called an equivalent ratio, okay? And it could be dividing the top and bottom or multiplying the top and bottom to get the other fraction. We're calling them ratios here, okay? So anyhow, a special type of ratio that has both terms expressed as different units is called a rate. Okay, a rate. Yeah. We'll talk about special rates in a second. And all right, this next one is something you guys probably don't know of. But if there's a fraction in the top and the bottom, that's called a complex fraction. Okay, it's basically a fraction inside of a fraction. All right, that's a complex fraction. Make sure you guys are taking good notes here. And anyhow, we'll keep on rolling. Here are some things that you should be able to do. So let's see if you can figure these ones out here. You can pause the video and go ahead and try to figure out 5 through 10. All right, if you have no clue what you're doing, it's all right. Here, let me show you how to do one, and then you could pause it and do some more of them. All right, so 4 boys to 7 girls. So you want to see how you're going from one fraction to another. Okay, so here it's 4 becoming 8. Okay, so when you are finding equivalent ratios, you're looking for what you can multiply the top and the bottom by. Okay, and it has to be the same number. So how do I go from 4 to 8? I times it by 2. So to go from 7 to something, I'm going to times it by 2 because I times the top by 2. All right, so 8 boys to 14 girls would be an equivalent ratio. Okay, so equivalent ratios are basically fractions that are the same. All right, so hopefully that isn't so bad. Let's see here, 16 tires to 4 cars. And this one, you are getting smaller. Okay, so here you're trying to figure out what you would divide the top and bottom by to get the same thing. All right, so you take 4, divide by 4, you get 1. And then so you divide the top by 4 as well. Okay, so you get 4 tires per 1 car. Okay, see this next one. 8 to 10. So I'm going to be multiplying to get 50. So you're going to multiply the top by 5. So it'd be 40 to 50. 40 correct to 50 total. All right. This next one, you're going to be dividing by 2. So you get 10 opals. Here, you're going to be dividing by 4 again. So 8 pencils to 2 erasers. Here, you're going to be multiplying by 3. So this is 21 balls, 27 bats. All right. Now, here it says write each situation as a rate. All right, so when it says write it as a rate, that's really not super clear what they want you to do, but Basically, to make it a rate, you make it into a ratio. So like 150 miles in 3 hours. Okay, so typically, when you see time and distance, it's distance compared to time, like you're going miles per hour. Now, there is no like reason why you couldn't write it the other way. Okay, it just is not the typical way to do it. Now, if you reduce this, okay, you could write it as 50 miles in 1 hour. Okay, and this is what we call a unit rate. Okay, so this is an important term here. It's called a unit rate, which is the rate per one. Okay, so anytime they ask you to find a unit rate, you're trying to figure out how much per one. See, 50 miles per 1 hour. Okay, so 5 apples in 2 days. All right, so once again, you can make it into a fraction, 5 to 2. All right, and now you can make this fraction a unit rate by dividing it. So you take 2 into 5. Okay, 2 into 5 is 2.5, okay, or 2.5. So it's 2.5 apples. And it's really critical when you're doing this lesson here that you put the units on your answers. 2.5 apples per 1 day. And I am writing on my face, which is kind of weird. All right, I just moved my face out of the way. I don't know if you can see my face, but I can. It just moves there. Okay, pretty weird. All right, so there you go. That's what we call a unit rate, and that's what we're going to be doing a lot of in the next section here. All right, number 13, write an equation to represent the pattern in this table. All right, so it says write an equation. Anytime it says write an equation, you need an equal sign. Okay, so what you're trying to do is figure out how do you go from x to y here. Do you see any, like, am I adding? It has to work for all of these. Am I adding a number? It's increasing, so could be adding, but it has to be the same thing for all of these pairs. Like, how do I go from 4 to 12? How do I go from 5 to 15? 6 to 18? Okay, 8 to 24. All right, if you haven't figured it out, I am multiplying by 3 to go from x to y. Okay, so my equation would be, okay, 3. So I'm taking 3 and I'm multiplying it by x, or simply 3x. So when you write 3x like this, it means 3 multiplied by x. And what is that equal to? That's equal to y, okay? So 3 times x equals y. So always do something to x to get y, okay? You don't want to do something to y to get x. At least that's not the typical way to write equations, all right? You're trying to get y by doing something to x. Okay, so let's take a look now at this particular actual section. So you'll need to turn your book to this page, which is lesson 3.1. Alrighty, let me tell you the page number in one. Alright, here we are on page 163. I found the page number and wrote it up there for you. Okay, so there's a nice little example of how ratios are useful in real life here. So we have a basketball contest. Elizabeth made 9 out of 25 free throws. Alex made 8 of 20 free throw attempts. Jenny said that Elizabeth had a better free throw record because she had more free throws than Alex. All right. So is that a truthful statement? Do you agree with Jenny's reasoning? Is she the better one because she made more free throws? Well, we can't really know for sure, to be honest. Her reasoning, a little faulty here, okay? If I shoot 100 times, I'm probably going to make more than if somebody shoots 20 times, just to exaggerate that a little bit. So a good way to compare these ratios is to equalize them somehow. And the best way to equalize them is, well, you could do one of two things. You can make them both into decimals, all right? Or you can try to figure out a common ratio that they would both, or a common denominator that they both could be written as. So 9/25 and 8/20. Does anybody know, like, what denominator we could maybe change both of these into? How about 100? Okay. See, you could make 20 into 100, and you can make 25 into 100. Not so bad, right? So 25 becomes 100 by multiplying by 4. So 9, if we multiply the top by 4, it would be 36. So if we continued at this same rate, okay, as this Elizabeth ratio, I'd make 36 out of 100, or Elizabeth would make 36 out of 100. All right. Alex, on the other hand, would have made a total of 40 out of 100. So that means Alex has the better rate, okay, the higher ratio. His ratio is, if you make it into a percentage, 40%, versus Elizabeth is only 36%. So, do you agree? Nope. All right, a little crazy there. But that's just a little way that we can use ratios, all right? So another way that we could use it is, well, figuring out your pay rates. If for some reason the job didn't tell you how much you were making, and they just give you a bunch of pay for a certain amount of time, you could figure out how much you make per hour, roughly. All right? So here, Nathan and Dan were hired as lifeguards. Okay, they received their paycheck, but who received more per hour? All right, so now notice when you're finding money unit rates, all right, a unit rate with money is typically written as a ratio comparing the money, okay, so you want to have the money divided by the amount of time or the amount of quantity, okay? So it's always money on top divided by whatever quantity is on the bottom. All right, it could be hours, it could be gallons, it could be years, it could be whatever on the bottom. But when you see money, typically it's comparing money to so many units. So try to keep that in mind when you're figuring out your money unit rates. All right, so in this particular lesson, I am going to let you use calculators because it will save you a lot of time. In fact, I think this chapter we're going to let you use calculators for all of it. I'll let you know otherwise. But anyhow, so to figure out Nathan's pay rate, all right, all we have to simply do is take 46.25, the money, divided by the hours, and you get Nathan's pay rate, which is $9.25 per hour, and Dan gets paid $8.75 per hour. We're dividing Dan by 9 because that's how many hours he worked. All right, and now if we want to compare these two rates, okay, you cannot compare them when the denominators are different, but now that we made them unit rates, we can now compare them and see who made more money. And the man who made more money, Nathan. Nathan by 50 cents. And how did we get the 50 cents? Well, you simply subtract 9.25 minus 8.75, okay? So after you have unit rates, you can compare them, all right? Provided that the units are the same, of course. You know, here we're comparing dollars to hours by subtracting, okay? So you subtract these and you get 50 cents different, or half a dollar. All right. So here is another little problem about Jennifer. She's making money too. You have to figure out her unit rate. All right, so you can pause the video and get out your calculator, and I want you to calculate Jennifer's unit rate. Okay, we're back here. I hope you figured it out. You could use a calculator here. Take 137 divided by 15. You get 9.15 per 1, or 9.15 per hour, $9.15 per hour. They want you to show here that you're dividing both the top and bottom by 15. You don't really have to write this on your work. I could kind of understand that if you don't. So anyhow, here's a convince me question. What do you notice about the models used to find how much each lifeguard earns per hour? Well, in all of these models that we used, just to remind you guys, the money was compared to the hours. And when we finally compared the correct and figured out who was making more, we found the unit rate. And so we made it into money per 1 hour. And all you simply have to do is take the money and divide it by the hours to get that. Alrighty, well that's it for this video. I'm going to probably put up part 2 here in a second, so stay tuned.